We can start by taking out our highlighter and highlighting the word logarithm to see that it's inverse of a power. So if we have y equals 10 to the x, then log base 10 to the x would be the inverse, and that equation or the graph of that inverse could be found just by reflecting over the line y equals x. Because anytime you graph something over the line y equals x, you get the inverse. And something about changing a graph, when you graph an inverse, what happens to the coordinates? The coordinates get switched. So notice on our red graph, y equals 10 to the x, we have the point 0, 1 and 1, 10. Whenever we graphed any exponential function, those were the important points that we always labeled. Always 0, 1, and always 1, whatever the base was. In this case, the base is 10, so we have the point 1, 10. Notice on your blue graph, you have 1, 0 and 10, 1. Does it make sense that on any log graph, this is log base 10, but we can have log base 5, we can have log base 7, we can have log base 3. On any log graph, you're going to have the point 1, 0. And you're going to have the point base, 1. Now, log base 10 of x is called the common log. And the common log, because it's written so often, doesn't have a number there. So if you see no number, if you just see log x, it means base 10. If you go to your calculator and find the log button right here where it says log, that will be just base 10. So if I do log of 10, right, according to my graph, I should get what answer? Right? If I do log of 10, what answer should I get? 1. Okay? So if I push enter, do I get 1? Yes, I do. What's another point on the red graph that you could label? What's another coordinate on the red graph? It might be way off the graph, that's fine. But what's another point you could plug in? What would you get? Something, something. 2, 100. Right? Does that make sense? If I plug in 2 for x, I'd get 100? Does it make sense that on my log graph, way over here, I would have, switch the x and y, 100 over 2? Test it on your calculator. If you take log of 100, do we get 2? Yes. So one of the things that we're going to have to do with this is we're going to have to graph logarithms. And we're going to have to graph logarithms with all the transformations. And another thing we're going to have to do is really learn how to work with a log equation. And it's probably, well, it's not the first time that you've had kind of a word. Because with sine and cos, you have kind of a word for a function. You have sine of x, cos of x. Now we have log of x. But it's kind of weird because it's connected to an exponent. So at the bottom of your page, we have a definition of a logarithm, and I'd like you to write this out underneath. That you can take anything in exponential form and rewrite it in logarithmic form. This is what the definition of a log is. That green arrow thing means that those two things are equivalent. The base in exponential form corresponds to a base in logarithmic form. The exponent in exponential form is the answer in logarithmic form. And the whole reason we have logarithms is to solve for exponents, so it makes sense that the answer would be the exponent. And the answer in the exponential form is what's inside of the logarithm. So one of the first questions that we do is that we just practice writing it from one form to the other. Okay? All of these expressions are true. Would you agree that 3 cubed is 27? So what we need to do is we need to write this same thing in logarithmic form. So how do we write this same thing in logarithmic form? The base of the exponent is 3, so the base of your log is 3. Okay? Logs solve for exponents. That's their main purpose. So the answer is going to be what your exponent was originally. And the number that's left, the 27, the answer of your exponent is going to be inside of your logarithm. And we would read this and say log base 3 of 27 is equal to 3. That's how I would read it. When I see a logarithm, like if someone said, what's the answer to log 3 of 27? I always change it to an exponential because you're much more comfortable with exponentials. When you see log 3 of 27, right now it just looks like the word log and some numbers, and you don't really have a relationship with this logarithm form or anything like that. So I kind of put a question mark right there. And whenever I see a logarithm, log 3 of 27 really means 3 to what power, 3 to what exponent would equal 27? And the answer would be 3. And what this definition, okay, and I'm going to call it a definition because that's what it is, but the thing about definitions is you have to memorize them. You have to know what the definition is. If you don't know what a definition is, you're not going to be able to solve anything in this unit. So it's a really important thing to know what it means. Okay, that was part I. 5 to the negative 2. So changing this into a log. The base is 5. The answer is 1/25. Logs solve for exponents, so the exponent is what would be on the other side. So we'd say log 5 to the exponent of negative 2, or sorry, log 5 of 125 is equal to negative 2. Would you agree? 4 to the 0 is 1. And so when I change this to log form, we have log base 4 of 1 is equal to 0. What's 5 to the 0? 1. What's 7 to the 0? What's 82 to the 0? 1. Does it matter what base I have to the 0? As long as it's not 0, it's going to equal 1. So in logarithms, we have that log of any base of 1, okay, is equal to, again, here we would say, okay, if I had log base A of 1, I would think in exponents and I'd say to myself, A to what exponent would equal 1? And that would have to be 0. So one of the things when we have an exponential equation, sometimes we want to write it as a logarithmic equation. And we can switch them back and forth. Same thing if we have a logarithmic equation, sometimes we're going to want to change it to an exponential equation. So in part B, now all of these are in log form. And it says log 7 of 49 equals 2. When you see it that way, your gut probably doesn't go, oh yeah, that makes total sense. But if I wrote it in exponential form, the base is 7, the exponent is 2, is equal to 49. When you see 7 squared equals 49, does your gut say right away, yeah, that's right? Okay? But we're not there yet with logarithms. You might, at the beginning, find that a lot of time you're changing from a logarithm to exponential form because you're more comfortable with that. Sort of how at the beginning of trigonometry, you changed radians always back to degrees because you were more comfortable with that. Eventually, you got comfortable enough with radians that you were fine to deal with them. We want eventually to do that with logarithms, but it probably won't happen right at the beginning. Right? Log of 4 of 1/64 is -3. Does that make sense? Well, if I did 4 to the -3 equals 1/64, does that make more sense? And then you'd say, well, I'd have to know my exponent rules. Oh, yeah, that really makes, if I change that -3 to 1/4 cubed, then it makes even more sense for me. And the third one, log 10 of 1/10,000th equals -4. So 10 to the -4 is 1/10,000. Okay, so practice. This is important right now. Be intense in a little bit. Really practice these questions 5, 6, and 8. Get yourself used to the definition of a logarithm.